In this video, we are going to see how can you use push operation when stack is implemented using array as well as using linked list. So first we will check on the implementation using array. Suppose we are going to create a stack which have n elements. So this is our stack using n elements. Because it is an array, we have predetermined how many elements we are going to use in our stack. So at the first, our top will indicate to -1. So index is here 0, 1, 2 and here is 3. So first it will indicate to top is -1. That means our top will remain here. Here is our top. And I also declared a variable called full, which will indicate the last index, that is n-1. In this case it is 3. Now first of all, before entering any element in the stack, we are going to check if our stack is full or not. So if our top is equal to full or not. In this case, now top is -1 and our full is 3. So they are not similar. But if they are similar, then we are going to print the stack is full, or we cannot enter any mode element, any error message you can want. Now if our stack is empty or if our stack is half full, etc., etc. So then we are going to increase the value of the top by 1. That means right now our top is here, that is -1. So when you are going to enter any element, our top should indicate the position where we going to enter the element. So in this case, if we increase the top by 1, then from -1 it will indicate to 0, and then you can add the element. Suppose we are going to add an element called A. Then if you again want to increase the elements, or if you want to add next element, then you have to change the value of the top by 1. So it will indicate now here in this position 1, and then you can enter the next element. It will continue until your stack is full or until you don't want to enter any more element. So entering the data in the stack when it is implemented as array is very simple, and you can do it in this way. Now we are going to look when you are implementing the stack as the linked list. So first of all, when are you going to implement your stack as the linked list, we have to allocate the new node. Here it is, the name is new nd. It is the new node. You have to allocate a memory to this node. Now in case of linked list, suppose there are right now say one item here. This is the very first item, or say it is here. This is the first item, say it contains A in it, and it points towards null because no any more item is here. So right now top is indicated here. Top is indicated here because we know the top is indicating to the node to which a new node will be entered. So our new node will be entered here in this location. So first of all, the new node, new nd, will get a memory, and then we will check if the memory is available to it. If no memory is available to it, then we will simply print no memory received. But what if it gets a memory? So I am denoting the new nd in the diagram as say n. This is my new node I am going to enter. Now as you know, the linked list has two parts. One is the information part, another is the link part. So if the memory is available to it, now entering some element to its information part and then provided the link part as null. So say the information is B. This is my new nd node, and the link is here like that. So this node I am going to enter in my stack. So first of all, we are going to change when we are going to enter the element to my stack. We are going to change if my stack is empty or not. For this we are going to check if my top equals to null or what. Now my top equals to not null, but if it's null, then we can simply assign the new node as our top element. But if it is not empty, the stack is not empty, first of all, what we are going to do, we are going to save the top location to a temporary variable, say lock. So now another reference variable will point to it. Say the name is lock. It is a temporary variable. You can write any name you want. So it is a temporary variable which points towards the present top item. Now we'll shift this top pointer from the presently top to the new node we are going to insert. So now it will indicate the top. So this is our new top now. We shift it. Now then we have to link this link to the previous top. Now previous top's value is stored in the lock. So we just simply link this to this. So the link part of new ND will now point to lock, the temporary variable in which we saved the previous top. So whenever we make this link, then it points toward the previous top. So now the link connected. So using this method, you can push any new node to the stack using linked list.